My name is Ethan Wells.
My name is Mason Turner.
I'm Landry Lee.
And we are all from the United States Military Academy at West Point, New York. And our teacher was Major Musselman, who was also our sponsor. And we won the Outstanding Award for SCUDEM in solving Problem B, punishing infants.
Throughout this presentation, we're going to show you how to choose your prompt, making sense of the prompt itself, creating the project, solving, iterating, and presenting.
So first we'll go over how to choose your prompt. So when you're selecting your prompt, you're going to want to ask yourself 3 questions. Are you actually interested in the prompt? Do you have any experience in that area or in the area that the problem is being asked? And can you actually envision yourself working out the problem?
So for us, choosing our prompt, right, the SCUDEM challenge has 3 problems, right? So prompt A, prompt B, and prompt C. And just kind of a general overview of all. So prompt A is about kangaroo care. So the goal of that was to develop a model of the interactions between infant kangaroo and its mother, or human baby, and its mother under the KMC treatment. Prompt B, which is one we did, was to develop a model that includes different populations and their different propensities to act out aggressively towards others. And then lastly, prompt C, we have the dog cannot catch. And this was, you watch a video and you use different analysis of that situation to determine if it's clumsy or not, right? So obviously we went with prompt B, right? Because going back to kind of the framework, we kind of had some background in this. We were already in a differential equations class, and we thought it would be a kind of seamless transition to kind of create this differential equation model for these different populations.
For understanding the task, first you want to make sure you read the question and thoroughly understand it. Figure out what the question is actually asking you to model and what you might have at the end of your project. Look at the provided research for each problem. So when you're looking, one, at the selection, but then also once you choose your problem, make sure you look into that research and then also extend the research. So you can look online, look at other journals and literature on that problem to find out more research about it. And then finally, brainstorm how your graph or model might look at the end and what results you want from your model.
All right, next you need to look into research and literature about the prompt. The prompt itself gives you a little bit of research first, and that's really helpful for initiating your differential equations and solving the problem. However, you need to look for key terms within the prompt itself and search for it on the internet or in books. And what we found that cyberbullying really affects the propensities itself to antisocial behavior in humans.
All right, so kind of moving to our actual model itself. So the kind of approach we took and that we suggest future SCUDEM people take, at least for differential equation work, is you want to kind of start with a pre-existing model that kind of relates to your model, right? So for us, in our case, we chose the competing species model, which is a basic model kind of like the Lotka-Volterra model, in that there's a few slight differences, but the main ones being we have 3 different parameters here subtracted from each other, as opposed to the 2 different ones in the Lotka-Volterra. And right, so we start with this simple model, and you kind of expand upon it based off of the different factors and parameters that we want to add, right? So this way, you're not essentially creating or reinventing the wheel per se. You're not creating your own model. You're just kind of working off something that's already been made. Because plenty of researchers and analysts have come up with this model, and that's why it's kind of, you can use it to build upon.
Next, when you're making your innovation, so you're going to want to add to something or add more into your model than just the basics. So the first thing with that is you want to manage your expectations in the project. You only have 3 weeks to finish the project, and that includes making your model, making graphs and a presentation, and then actually presenting and submitting it. So manage your expectations and how much you're actually going to be able to create with your innovation. But with that, the easiest way to add innovation to it is by adding complexity 1 step at a time. So you're going to look at your data and research and start adding complexity to match that research you found. Another thing that's helpful is if you use your modeling software while you're adding complexity to the steps. That way you can see what's happening to the graphs in the model in real time as you produce it. In our case, we had a competing species model, and then we added 1 step of complexity by making it under a shared population. And then the next step, we added limits to that shared population and produced our model.
All right. Oh, go ahead. Sorry.
I was gonna say, so kind of this is the solve step, right? So we had to figure out which software model to use, right? So in our case, we used Mathematica because that's what we were familiar with in class, and we had kind of been used to like creating functions and parametric plots, right? But I know a very common resource is MATLAB and Manum. MATLAB probably more. We just thought kind of practicality-wise, right? We only have 3 weeks. It's going to be kind of hard to learn this new interface, and so just stick with something we've kind of already been familiar with was kind of the easiest. And then using that software, you want to, like privately said, you want to continue innovating your process, continue checking your model, and making sure that your model makes sense and does what it expected, because sometimes you'll get some graphs, like I know we got some graphs sometimes that were kind of crazy, and like if we had just kind of said, oh, okay, that's fine, then our model would not have gotten where it eventually went.
All right, for the interpret stat, you need to put your equation into the context of the prompt and the problem. So you need to explain variables and parameters. Those will give you, or that'll give the audience what you actually put into the equation. So what independent and dependent variables, what changed and what stayed the same. And then you also need to give them assumptions so they're not left questioning what did you leave out or what did you not include. And then what can the problem tell us, or what can this tell us about the problem? You want to tell them what the solution did and what it predicted.
And the final part, you're going to present what you've learned and what you've made. So the first, or the last step will be you're going to have a 5 to 10 minute video explaining your entire process and your model. So the first thing is creating a presentation. In this presentation, you're going to explain the full prompt and what was a part of it, and then all the research you did with that prompt. And then you're going to explain the variables you used in your model. You'll explain all the equations you produced and how you came up with those equations. You'll show and explain all the graphs for your model. And then you'll interpret the graphs as well as your equation to produce some sort of solution. And you'll draw conclusions from those graphs and your research. While doing this, you want to make sure you're using mathematical language and being very, very thorough in your explanation and how you came to your solutions.
Any questions?
So I have a question, right? So what's kind of a problem that y'all might have faced in your modeling process and like with the model itself, and how did you overcome that?
Well, one problem we always faced was inside of Mathematica, we would be producing our model and sometimes we would have like weird errors, and a lot of it was just brainstorming how can we possibly change our equation to fit our research better. So it's just a step-by-step, continuously tweaking the model to figure out what was the issue and how we can solve it.
And then one more question. So how did you kind of arrive at your final solution, and what do you suggest, what is some advice you give to people in the future participating in the SCUDEM challenge?
So how we arrived, we iterated over and over and relied on our research to help us guide through that. And what especially helped us was defining our variables, parameters, and assumptions first. So if you start all that early, eventually you'll get there.
What's some like advice though for some for people doing SCUDEM in the future? Like how would you suggest they like manage their time or?
Oh,
like that?
definitely start early. Schedule time with your team. Go into find the collaboration spaces.
And to add on to that, make sure you divvy out your time. So plan how long you think it's going to take you to produce your model, whether that's 1 to 2 weeks. Schedule that out, produce your model, and then after that start producing your graphs and everything you'll need for the presentation, and then produce your presentation and finally record and edit your video. Try to space all of it out. That way you have plenty of time to work on it and plenty of time to brainstorm and get through each step of the process.
Well, thank you.